11 laws? That's quite a lot, isn't it? But we are sure you found some of them to be obvious, like being told that biryani tastes good or paper cuts hurt, just general knowledge. And because all these laws apply to our set R, we can call it a field. In maths, a field isn't a beautiful open space with grass that we are used to, but a different kind of beauty. In a field, you can add, subtract, multiply and divide real numbers. Now, our purpose of learning these laws is quite obvious. Yes, to apply them. Have a look at our first example for instance. It asks us to prove that a real number a, when multiplied with 0, results in 0. And you must be thinking that what's the point of proving that as anything multiplied with 0 is 0? But let's not forget that this lesson is about applying the properties. So, let's prove this. Taking the left hand side, we will use the additive inverse property to expand it. As according to it, 0 can be written as 1 plus -1. We'll remove one pair of brackets to make this a simple subtraction. Now recall the distributive law, which said that the number outside the brackets can be multiplied by the numbers inside individually. Remember this? Let's do the same thing here. Now, anything multiplied by 1 is just itself according to the multiplicative identity. This now looks like the sum of A and its negative counterpart. Excellent job so far. What now? Well, thanks to the additive inverse property, the sum is 0. And that's how we show that with the help of learned properties, the product of A and 0 is just 0. Now, let's move on to the next example. Here, we need to prove that if the product of the two real numbers is 0, then either of the two real numbers must be 0. Let the two real numbers be A and B. And if their product equals 0, then either of them must be 0. Makes sense, but we need to prove this. Start by calling the product equation 1 and suppose A isn't 0. Then what is the value of B? If we multiply the inverse of A with equation 1, we get this. And multiplying the same value to both sides of equation doesn't affect the equality. Says who? The multiplicative property of equality. So far, so good. Now that we have set up the equation, we can rearrange the left hand side using the associative law of multiplication by enclosing A and its multiplicative inverse in brackets. Recall the product of the multiplicative inverses is 1. And now we are left with this. The multiplicative identity property tells us that any number multiplied by 1 gets itself back. Hence, the left hand side is now just B. And we did it. We just proved that if the product of A and B is 0, then at least one of them has to be 0 too. By assuming A wasn't, we found that B had to be. Try practicing on your own to see what happens when we assume the opposite. The same method should work. And that's it for the first example. That was quite simple and easy, wasn't it? Even though the equations seem obvious, we broke them down further and saw how so many of the laws played their part. We will resume having this kind of fun in the next video.